Welcome to this comprehensive guide on building scalable systems. We will explore how disciplined planning transforms vague ideas into robust, maintainable software architectures that grow effortlessly. Software success hinges on planning. OOAD transforms vague ideas into structured solutions. This disciplined approach prevents crumbling systems. We will explore core principles to build scalable, maintainable architectures from day one. Before diving into the steps, we must distinguish between the two distinct phases of this methodology. Analysis defines what the system must do, while design determines how the system achieves those specific goals effectively. This phase acts as a deep inquiry into the problem space, ensuring we fully understand user needs before writing a single line of code to solve the identified issues. Here we translate abstract requirements into a concrete blueprint, determining exactly how objects will interact to fulfill the business logic defined in the analysis phase. This paradigm mirrors real-world entities, making the resulting code significantly easier to understand, modify, and maintain as the project grows in complexity over time. These four fundamental concepts form the bedrock of any successful OOAD implementation. Mastering them ensures your system remains flexible, secure, and easy to extend throughout its lifecycle. By hiding internal components, this principle prevents unintended interference and misuse, ensuring that data integrity remains protected from external manipulation. This allows developers to focus on high-level interactions rather than getting bogged down in the intricate internal mechanics of how specific objects function. This mechanism promotes significant code reuse and establishes a natural hierarchy, reducing redundancy while maintaining a logical structure within the system. This flexibility allows different classes to respond to the same message in unique ways, making the system adaptable to changing requirements without breaking existing code. The analysis phase begins by capturing the problem space through a clear inquiry into who interacts with the system and what they aim to achieve. This step sets the stage for all subsequent modeling efforts. You must list every user, hardware device, or external service that interacts with your application to ensure no critical stakeholder is overlooked during the design process. Documenting these scenarios helps anticipate edge cases and error flows, ensuring the system behaves correctly under both successful and failure conditions. By mapping out what happens when actions succeed or fail, you create a robust foundation that anticipates real-world usage patterns and potential user errors. Once actors are identified, we must define the key concepts within the domain. This step creates a shared vocabulary and establishes how these entities connect to form a cohesive data structure. By identifying core concepts like book or member, you create a shared language that bridges the gap between technical developers and non-technical business stakeholders. This connection indicates that one entity relies on another, such as a member borrowing a book, establishing the fundamental links between different objects. Understanding whether objects can exist independently or depend on each other is crucial for managing data integrity and lifecycle events within the system. Moving into the design phase, we translate conceptual analysis into a technical blueprint. Class diagrams serve as the backbone of this design, visualizing the structure and responsibilities of every component. These diagrams act as a map for developers, ensuring everyone understands the structure and how different parts of the system fit together logically. Clearly marking access levels ensures that internal implementation details remain hidden, preventing external code from breaking the internal logic of your classes. Focusing on a single purpose prevents classes from becoming bloated and difficult to test, keeping the codebase clean and modular for future changes. While static diagrams show structure, dynamic diagrams reveal how objects interact over time. Sequence diagrams are essential for understanding the flow of messages required to fulfill specific use cases. This visual layout allows you to trace the chronological order of interactions, making it easy to spot logical errors or bottlenecks in the system flow. Mapping these messages helps identify unnecessary communication paths and ensures that the logic flows logically from the user action to the system response. Adding details about loops and conditional logic ensures that the behavior model accounts for all possible scenarios, including error handling and repetitive tasks. Design patterns provide proven solutions to common software design problems. Using these templates ensures your system is flexible, maintainable, and scalable without reinventing the wheel for every challenge. This pattern is ideal for managing shared resources like configuration managers or database connection pools, preventing redundant instances from consuming memory. By allowing subclasses to alter the type of objects created, this pattern makes the system more flexible and easier to extend without modifying existing client code. This pattern is perfect for event-driven systems, ensuring that all dependent objects update their state consistently whenever a source object changes its data. Scalability requires a system that can handle growth without a complete rewrite. Achieving this involves enforcing strict modularity and separating concerns to isolate changes effectively. This isolation allows you to update the database layer or user interface independently without affecting the core business logic, ensuring stability during changes. When a module contains only related functionality, it becomes easier to understand, test, and maintain, reducing the tangled web of dependencies that often plagues large systems. By depending on interfaces rather than concrete implementations, you can swap out components easily, making the system adaptable to new technologies or requirements. As systems grow, they must handle multiple users simultaneously and evolve through continuous feedback. Planning for performance and embracing iteration are key to long-term success. Implementing locks and caching ensures that the system remains responsive and stable even when multiple users access the same data simultaneously. By offloading heavy computations to background threads, the system maintains a smooth user experience while processing data efficiently in the background. Design is not a one-time event. Regular refactoring and updates based on user feedback ensure the system remains aligned with evolving needs and constraints. Even with a solid plan, mistakes can derail a project. Being aware of common pitfalls helps you avoid unnecessary complexity and maintain a clean, functional architecture throughout development. It is crucial to keep designs simple until complexity is proven necessary, avoiding the burden of maintaining unused features that complicate the codebase. Splitting responsibilities across multiple classes prevents maintenance nightmares and ensures that each class remains focused and easy to test effectively. Robust error handling and configuration management ensure the system can recover from failures and adapt to changing environments without requiring code changes. To recap, the journey from idea to a scalable system follows a logical progression of analysis, design, and continuous improvement. This structured approach transforms vague ideas into concrete, maintainable solutions. This foundational step ensures you fully understand the problem space before attempting to build a solution, preventing costly mistakes later in the development cycle. Translating requirements into a technical blueprint ensures that the system structure is robust, flexible, and ready for implementation and future scaling. Continuous iteration and refactoring keep the design aligned with current needs, ensuring the system evolves gracefully as requirements change over time. Thank you for joining this journey into object-oriented analysis and design. Remember that no design is perfect from the start, but a solid foundation supports change and growth. Start small, focus on clarity, and let your architecture evolve with the needs of your users.